Welcome to the Navitas Design and PDK department. My name is Marco Giandalia and I'm leading this department since I joined Navitas in the early stage. The first things we did at this department was developing the world first GaN IC technology and its relatives process design kit, or PDK. The PDK is a very important piece of software that brings all the elements of the technology into the design environment. And here we have Mer, who is the head of the PDK development, and Victor, who is our lead design architect, and they will bring you into several very interesting aspects of these topics. Navitas is the only company having a GaN IC PDK that allow us to design chip and cover all the aspects of the analog design flow, specifically including a very innovative device modeling that allow us a very accurate simulation at each individual transistor level inside the GaN IC. Way more accurate than the traditional Berkeley BC models that are not suitable for GaN and our competitors cannot have. By using our PDK, we have developed the first GaN IC monolithic, integrating a gate driver into the same die of the power FET, and by doing so, we have enabled a switching frequency in the power converter that is up to 20 times the switching frequency of a similar silicon converter, and also with much higher power efficiency. This overall has brought the power converter to increase the power density by a factor of 4 in the market. Meyer, would you mind to tell us what is special about the Navitas PDK?
PDK is a software recipe that enables us to have first-pass products by having unique devices, models, and rules. It allows us to adhere to the electrical and physical constraints of a process. And we can do this by having the right building blocks of the PDK. We have low voltage devices, high voltage devices, resistors, and capacitors. We do things differently than a typical fabless semiconductor company. A typical fabless semiconductor company would adopt the foundry PDK. What we've done is we've developed all this internally from scratch. If you look here on the upper left, you'll see that for our models, we have extracted the entire variance of parameters like VT, which is the threshold voltage, across all the temperature. We have also captured all the topography, dielectric composition and thicknesses, all of the relevant electrical parameters for the conductors. All the SOA, safe operating area checks, are embedded in the PDK along with the leakages of the devices, the drain to source leakages and all the rest of the leakages. We've gathered years of reliability data that we have also put into the PDK, along with the high voltage spacings, the enclosures, the LVS. With all this together, we were able to build a small, as you can see on the right, a tiny QFN 5x6 millimeter package as one of our devices. We have many great products out there. We can create this monolithically integrated GaN IC with SCP, short circuit protection, OTP, over temperature protection, current sense, and voltage regulation. We can also protect the gate of the power FET by ensuring that the LDIDT, the parasitics associated with the package, are no longer existent because the driver is so close to the actual power FET. So we have ensured reliability. We can shrink the drain to source terminals and make them extremely small, which will increase the gross die per wafer. So it decreases our manufacturing costs, also lowers the BOM, bill of materials, for our customers because the passives decrease in size when we go to higher frequencies. Now next I want to introduce Victor Sinau. He is our lead architect designer. Graduated from MIT. He's got a lot of experience in design and applications, and he will explain the details of our monolithic GaN IC and how it relates to our PDK.
Thank you, Mayor. I'm just going to switch the slide here really quick. So one thing I want to make sure I point out is that our competitors, as Mayor said, generally will have access to the foundry PDK, which allows them to create a 650 volt power transistor from GaN and sell that as a product. That is what a number of our competitors do. But that approach is limited to the same pitfalls that you would have with any discrete semiconductor product, be it made out of silicon or any material, in that it must be separated from its gate driver, for example. And if you separate the two, you are limited in how fast you can turn the switch on and off, and thus how dense your power supply can be. At Navitas here with our proprietary PDK, where we're able to place not only 650 volt transistors, but low voltage transistors, resistors, and capacitors as well, we can create systems that do away with all those pitfalls. We can put the gate driver and other analog signal processing components monolithically together on the same integrated circuit. And what you see here, here's a schematic of what I'm suggesting. Our competitors can create just this single power FET, which is one element, but we can create a huge array of different circuits that allow us to make extremely reliable, very fast switching, very efficient power ICs. That's what we call a power IC, to enable our customers in ways that other competitors can't. Because of the modeling efforts that we've done, our reliability is extremely high. We can control very precisely what the gate voltage of the GaN transistor is. We can detect faults like short circuit faults, over temperature faults, and we can again eliminate the parasitics between the driving system and the actual power transistor. This is, I can't stress how important that is, because it enables a step up in frequency, as Marco mentioned, over 4 times faster, 20 times faster in switching speeds, which allows our customers to make, over 4x as dense power converters as they would otherwise be able to do. And just, you can see this big giant area that we have, which is the layout of the actual power IC. Most of it is the power integrated, or is the power FET, the 650 volt power FET. This small area up here is where we put all of our analog circuits, so we're not taking too much space away from power processing, and we're adding an incredible number of features that really differentiate us in the market.